Alright, so your this will be so starting today and a little bit of what we have done previously will be on your next test. Okay. A lot of this has to do with coordinate transformation. What we have looked at is fundamental rotations. Fundamental rotations essentially this means one zero 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 cosine theta. And R2 B is 0 1 0 0 0 sine phi minus sine phi. And finally so these are fundamental rotation, and when I say something like 1 theta, it means rotation about one axis. One axis is x axis by angle theta. Okay? Yes. In reality though, rotation does not happen about, so when you think about rotation, orientation change, for example, take a look at this, right? So take a look at this. What is this rotation about? What would you express this rotation about? Z-axis. Z-axis. Okay. Now, so if this is Z, right? This rotation is about, these are the axes, X, Y, Z. So this rotation is about X axis. And this rotation is about Y axis. So you can look at the roll pitch yaw as well. Okay, so this is rotation about Y axis is in the so these are roll pitch yaw, right? But does roll pitch yaw, if an aircraft takes a turn, does it do like this, and then this? No. It just does this, yes. Right? So the rotation itself can always be expressed about one axis, which is not necessarily a fundamental axis. Does that make sense? Not really. So when you do this, yes, right? Has it rotated about a fundamental axis? Not right. But can I say this is about this axis?
Yes. Oh yeah, you can take the axis.
It will always rotate. Now, similarly, this axis or this axis will be about this axis.
Yes.
Right? So you can do, about this axis. Sorry, about this axis. Okay? It's about this axis. Rotation can always be expressed about one axis, any rotation. But we don't quite understand how to express it. So what we do is we use a combination of these fundamental rotations, just like position. You know, if you want to express position, okay, do you need the three axes?
Right. Position.
Let's say the position of that vent over there, or the position of this computer in this axis. Strictly speaking, it is just this vector, right?
Yes.
The line joining. But then you have the components saying x, y, and z. So similarly, rotation you can express that in angles or fundamental rotations. Okay. So that's what we're going to take a look at.
Because this is just the same thing for the blueprint.
Alright, so look at this. Okay. This is a fairly involved figure. So please pay attention. Understand what really is happening here. If you're going to review the lecture later, and I'm looking at figure 4.15 in the third edition of the textbook. Okay. So here, try to understand what's happening here. What is the? Can anybody tell me what is the initial orientation and final orientation? Can you tell me the initial orientation? Oh, okay, let's start. What is the initial orientation?
Just the front,
IJK. Okay. So the capital IJK. I, J, and K. That's the initial orientation. Does that make sense? is the initial orientation of the frame. Do you see 1?
Yes.
Do you see number 1? Can you tell me what rotation is that?
Rotation
About the
K-axis.
About the
About the K-axis.
About the K
You're
axis.
rotating about the K.
What do you guys think?
It's I and K.
No, because you have an I prime with the
When you rotate on the XY plane, it counts as K. And then when you do K, J, it counts as I.
We're looking at the top right,
Oh,
He is right.
okay.
Which picture are we looking at?
the top right.
I thought it was good at the whole.
The rotation is always about one axis. Rotation is not about I and J. That's what I'm trying to get you guys to do. See, here it is rotation. This is rotation about what axis?
Yes.
X axis. This is rotation about Y axis, and this rotation is about Z axis. Okay. Tell me what rotation is 1 again?
So
Rotation of the
K.
Z axis or the K axis. Does that make sense? 1. If you see 1, by what angle?
Omega.
Cap omega. Okay. So if you have K, the first rotation, if you do this will come here, right? I prime. J will be J prime. Does that make sense?
Yes.
Okay. What is the second rotation about?
We're going to bottom right, right?
X-axis.
Yeah, it's about that. No, it's about I prime.
Hmm?
It's about I prime.
Is it about I prime?
Yes.
Yeah.
So it is about what axis?
The
X axis?
Yeah, it's about the X axis. But
Wait, that's what I said the first time.
Huh?
That's what I said the first time.
No, I asked you just one first
Oh, okay,
rotation.
okay.
Yeah. So the first rotation. What I'm asking you is this one.
Right.
So if you look at that one, that is there. You see that? So what you have to understand is, and that is what I asked you in the test, you should be able to flip this. You see, this is flipped. This IJK is flipped in there. Can you make this thing that is flipped? Can you make sense of that?
which one am I looking at?
IJK.
You're looking at it from the top.
Right, so look at this. This is IJK flipped.
Okay.
Okay. This I is this I. This J is this J. And K is simply coming out of the board, out of this thing.
Okay.
So when you want to express rotation about a particular axis,
You flip it.
that axis comes out.
Yes.
So in the exam, what I asked you was, give me an expression for rotation about Z axis. You remember?
Yes.
And the Z axis should have come out of the paper. Okay? Does that make sense?
Yes.
So here, your rotation is about, how do you express this rotation? Tell me.
How do we express it in like the R thing like that? So it would be
Rotation
R3,
matrix? Yeah.
Oh, so it would be R3, whatever angle.
What is that angle?
Omega.
Omega, cap omega. Okay?
R3,
R3 cap omega. So it will be this, but this psi will be
cap.
cap omega. So it will be cosine omega, sine omega. You understand?
Yes.
Okay. Now look at the second rotation. Can you look at the second rotation?
Yeah.
So okay, the second rotation is about
The
I
I.
prime.
I prime or the. Can I say it is about this?
Yes.
Can you apply this thing?
Yeah.
What angle?
I. Ain't the one the market is there.
Yes, good. So it is about angle I. Do you see that?
Yes.
So what will this be? 1, 0, 0, 0, 0.
Cosine I. Sine I, negative sine I, cosine.
Okay. Final rotation.
The third one is about the W with the angle of lowercase.
What is that?
The W. Huh? I thought the little one was the angle.
Huh?
That's the argument of parity.
So there is no W here. Is there a W?
It's a, yes.
Oh, there is a
Lowercase.
Little omega.
Lowercase and
Yes, yes, you're right. Actually, there is a W.
Yeah.
You're right.
In the inside is a little omega.
Right. So what about what axis the final rotation is about?
PQW.
So it's just
Oh, no. I thought we were asking about the parameters. Yes, about W. It's rotating about
Rotation is about a certain axis. Tell me what axis is it?
the
W.
W axis. Okay. So once you do the second rotation, what is the second this thing? It will be I prime, J prime, and W prime. Okay. And then about W you rotate by what angle? Little omega.
little omega.
Okay. Then which one applies? Which of these apply?
Oh, the second one. Because you just rotate it from I.
Rotating about
W, which is
K.
Oh, you're right. It is K. So
Right.
3.
Right. If the gear goes back to this.
Little omega. Right.
Okay. So you see the initial rotation and the initial orientation and the final orientation.
Yes.
What was the initial orientation?
JK.
IJK. What is the final rotation?
PQW.
PQW.
Correct.
Does that make sense?
Yes.
IJK is what frame?
Regular. ECI.
ECI frame. So here our IJK is this is one of the most startling discoveries Kepler made. Okay, so you really have to have a lot of appreciation for this. How do you go from ECI frame to PQW frame?
But quick question.
Hmm.
When you said IJK was a part of, I mean not IJK, you said PQW was a part of the EC. I thought that was part of the very part.
Perifocal frame, yes, that's what I'm saying.
Oh, okay.
So this is you're right. This is what frame?
The
The geocentric equatorial frame or the the ECI frame, right? Earth-centered inertial. You're going from Earth-centered inertial frame or the geocentric equatorial frame
right.
to the PQW frame. How are you going? From that frame to this frame? Can I write this as R? Do you understand this rotation?
So
The rotation matrix from, you read it in the reverse order, from ECI to PQW,
Okay.
okay, is, first rotation is about what axis?
Z.
Which one are you using?
Z to,
Is that correct?
yes,
Does that make sense?
yes,
Second rotation is about
X,
1, I, and the final rotation is about
Z again.
Oh, you put on based on the pictures. Okay, that's right.
Yes.
So that's how you,
Oh, so you
that's
write
the
it down.
correlation between the
Yes,
Okay.
exactly. What is
This
omega?
way. Omega is the angle,
What do you know about omega? What is this angle called?
it's beyond,
The right ascension.
Right ascension of
The
ascending.
ascending node.
No. What is I?
The inclination.
Inclination. What is omega?
Was what? The argument of purity.
Yes.
Argument of purity.
Okay. So understand this. So what we are trying to do is, you see how amazing this is. Just look at this. We have discussed these two frames, right? Okay, look at this.
What page are you on now, Dr. Franklin?
Huh?
What page are you on now?
Page.
Yeah.
172.
You know, pay what?
172. 172. Figure 4.14. So here, can you identify the equatorial frame?
Yes.
I, no, that's the, what's the name?
Equatorial plane.
Equatorial plane.
Plane. Do you see the equatorial? How do you equatorial plane? You see what you see here is what plane is that?
That's the orbital, right?
That's the orbital plane. Yes, absolutely.
So the equatorial, you would use it based off of the X, Y, and Z.
Not x, y, and z. When I say
It's the X. It says axis of the geocentric.
yes, exactly. So you see, you can either use this k, okay, or if you look at ij, ij is that plane.
Yes.
Does that make sense?
Yes.
That is the equatorial plane. Equatorial
Yeah.
plane, right? Plane which cuts through the equator. That's the equatorial plane. This is the orbital plane.
Yes.
Does that make sense? Now you see, about the axis of rotation, you move by cap omega.
Yes.
Imagine that, visualize that.
Yes.
Okay. This will become the new x-axis.
Yes.
Yes.
And you use that.
Then
You rotate about that.
you rotate about that by the
Back to
inclination.
Yes.
you get the W.
Right.
You see? If you get W,
Yes.
this K will align with W. Does that make sense? If you move above I-axis. And above W now, move this by small omega.
Yes.
I will align with E, J will align with Q.
I will align with E. J will align with Q. And then K align with W. Yeah. Okay. I mean that. Same that.
You went into the
EQW.
EQW. I want you to again visualize this. Okay?
Alright, you know, you visualize it one more time.
Yes. Okay. You are in ECI frame.
Right.
You are in IJK.
Correct.
Okay. So about K, you move
Wow, maybe.
cap omega by omega. What will this align with?
WI or your P.
Tell me what will this exactly align with? Anybody?
What exactly align with?
I.
will exactly align with at what stage?
When I move,
P.
No, it goes to that J line.
It goes to W.
Name.
No, that's Q.
IJK, you're in IJK plane, okay?
Right. Okay.
Frame. You rotate above the axis
Yeah.
by angle omega.
Yes.
Okay.
What will I align with? I'm looking for three words.
What I, little I or big I?
Bigger. There is no little I here.
Okay.
Line of notes.
Yes!
What
What do you say?
Correct. You got it.
He said what?
Line of nodes.
Oh, that's what it is.
It aligns with lines of node. Line of nodes. That's right. That is at omega. That is at cap omega. You get it? Does J align with anything?
No.
Not necessarily. You get it?
Correct. I see.
What we have done is, understand what we have done, okay? We have moved from, our angle was in the equatorial plane, right? That cap omega is in the equatorial plane. Small omega is in what plane? The orbital plane. It goes up like this. It is in the orbital plane, okay? Now, when you about the line of nodes, right? About the ascending line of node,
Okay.
you rotate it by I.
Yes.
What will K align with?
W.
W. What is that W?
That's your H vector as well.
H vector as well, yes. That is the angular momentum vector. And that is the PQW frame, PQW axis. It is the W axis of the PQW frame. Does that make sense?
That's perpendicular to the orbital plane.
It is perpendicular to the orbital plane. It defines the orbital motion. You get it?
Yes.
So now your K is aligned with W, okay? And P is aligned with P is aligned with line of nodes.
Oh.
Sorry,
No, by the time.
I is aligned with line of nodes.
Okay.
Okay. Now about this new K,
Right.
rotate this by cap omega. Your I will align with
Very axis.
very axis.
Okay.
Oh, it makes sense, you're right.
You're rotating by about K by that small omega.
Okay,
It I has to align. That is the angle omega.
correct.
It aligns with
Very axis.
Is it a capital way?
small omega.
Oh, okay. Alright, yeah, that makes sense.
That makes sense? How do you express that? The maths,
So do we express that by, since you know how I was at the monotone when it went to the periaxis, so will it still be considered 1 or 2?
3. Because K,
Oh, it is on the
3 axis, right?
Okay. And then we'll do it, the angle will be small omega.
Small omega. Yes. So now, what you have to understand is this rotation matrix, the multiplication sequence is reversed. I want you to either remember this. The math works out such that the multiplication. Do you understand what the multiplication sequence is reversed when I say that?
Yeah.
Oh, yeah.
The rotation sequence is what?
Right.
This.
Yeah.
The multiplication sequence is this.
Correct.
You get it? So here, how do I express the math itself?
That I do that.
How do I write the math?
For 1 and 4.
Cosine, little omega,
Yes.
sine, omega.
Cosine,
Cosine, little omega.
little omega. Sine, little omega.
Sine, 0.
0.
Negative sine, omega, cosine, omega, 0. 0, 0, 1.
Oh, so we're multiplying each matrix.
Yes.
Okay.
Pardon?
So this is going to be 1, 0, 0.
You guys are very active.
No, that's no.
Whoa. Double check.
It's
That's good. See, I like that.
It's scary. It's scary.
I like that. That's what I want you guys to correct me. Yes.
1, 0,
0.
0. Cosine I, negative sine.
Not just
Cosine
sine.
I, negative sine I, and then cosine. There you go. Then going to be cosine cap omega, sine cap omega, 0. Negative sine cap omega, cosine cap omega, 0, 0.
Okay.
Yeah.
So this is your
Figure out 9 months.
The rotation matrix of EPI to PQW.
okay.
Yes.
So here when you multiply, you get this matrix.
Ain't that so?
You understand? When you multiply this, you get this matrix.
You can just put that in your calculator.
You may not be able to put that in. Can you do that in your calculator? Okay. So you get that matrix.
It's my children. I do that.
Wait, can I do 4? I'm trying to make sure I got it right. Yeah,
But how would you do it? I've always done it with my calculator. So like,
So what you do is you take these two, multiply these two first. Okay? You can do it either ways.
so you just do the I times the cosine and make it.
Now you do this into this.
Okay.
plus, sorry, this, so 1 into cosine omega 0 plus 0 into minus sine 0 into 0.
Okay.
Then that is the first.
Then you do the second row,
The second, this one would be this element.
Okay.
So this would be this element. 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 You understand?
Yes.
Does that make sense?
And then you do it the same thing to the first one.
Yeah.
So does it matter if you do it if they're commutative or the assertive?
Huh?
Like, do you have to do it in a certain order?
It doesn't matter. Once you write it in this order,
You can do it in any.
yes, don't switch it. This multiplication sequence is important.
Well, that's what I'm asking. So can you do matrix 1 times matrix 2?
Yes, you can do this first and this.
Okay.
Or you can do this first and this. You can do that. It doesn't matter. You just don't want to do this first. Okay?
Can you write this like show how they got that first one? Not the like only.
I'll show you the first cell.
Yeah, like one.
First cell. Is that okay?
Yeah.
Okay. So the first cell would be, I need this one and this one. Right?
Yeah.
I need this and this for the first cell.
Oh, okay.
Or let me do this. So it is 1 into cosine omega.
Right.
Is that the only element?
No, we got the sign, the negative sign.
0.
Oh, yes, for this person.
1 into cosine omega plus 0 into sine omega plus 0 into 0.
Oh, okay.
Then you have,
okay.
I don't need this, right? I said I don't need this.
Right.
I'm going to need this.
Okay.
That means 0 into
Sine.
0
Oh.
cosine I
Cosine I.
into
Cosine cap omega.
cosine cap omega,
And then sine
Again,
I
0.
So 0.
right?
Yeah.
Then I need this.
Okay.
This would be,
So all of that's gonna be 0, 0. All is gonna be 0 except for the last one. That's gonna be cosine I.
no. So this is not the, this is this into this. Okay? Cosine I sine omega minus.
Oh, I'm confused again.
Got it?
No, hold on, wait.
It's this, so this element or this element is this into this.
Right.
This element is this into this.
Okay.
This element is this into this.
Okay.
Got it?
Time. I want to break.
This element, the center element is
Is the second row?
center row into center
Center
part.
line. Right. Okay. Center row, center line.
Okay. So I need this. It is 0 into 0. 0 into this is 0.
Right.
Cosine I into minus sine omega is minus cosine I sine omega.
Right. It is sine.
And that is, this is 0.
Right.
Okay. Now what is this element? It is
The
this
last row
into
to the
this.
left column.
Okay. So it is
So it will be 0.
0 minus into minus is plus. So you have sine I sine omega.
No, wait. Hold on.
This into this.
Okay.
This into this. Minus sine to minus into minus is plus. Sine I sine omega
Okay.
into 0. Into cosine I into 0. Okay?
It's long.
You're gonna give me half of
That's what it is.
Now,
I gotta work this out on my hand.
how do you do this?
So now you just add that section to it.
So now just look at this. Okay? So I'll still do this and get, see what I get. I'm just showing you the first element. It is cosine omega cosine cap omega. You see that?
Yeah.
Cosine cap omega cosine omega plus or minus sine omega it will be, understand how it is done. It is this column into this, sorry, this row into this column is this element, first element.
Oh, okay.
So it's cosine omega into cosine cap omega.
Right.
That is this. Sine omega into minus cosine. Sine omega, cosine I, sine omega.
Oh, okay.
So the minus sign remains.
So you do
You add
you do
this.
the middle, you do those two, then you do the first one with the total that you got for
You see that first term?
Yes.
Does that make sense?
Yes.
So this into 0 into, that is 0.
I just have to practice.
Okay, yeah, you just have to practice, that's it. Okay. So this is your rotation matrix. Now, try to pay attention here. In the exam, what I'll ask you is, I may ask you this derivation for 10, 12 points. Can you do this?
Which one?
This matrix,
The Q matrix?
the Q matrix. This Q matrix is nothing but this. I need you to do it with hand, not with calculator.
We can go with that.
If you're not going, I mean, you can put it in the calculator with just omega I and small omega.
Okay. So I need you to do it with hand and learn how to do it with hand. If I give you the rotation sequence, all you need is angles and axis. Does that make sense? What are the angles?
Omega.
Omega, I, small omega. Axis 3, 1, 3.
Aren't the angles the only thing that can technically change?
The rotation sequence can be 1, 2, 3. We'll talk about that. Okay. Rotation sequence, there's always you need 3 rotations.
To align.
So there are symmetrical rotations. 6 symmetrical rotations, and this should make common sense. Okay. What are the 6 symmetrical rotations? There are only 3 fundamental axes. That is clear.
Yes.
X, Y, Z.
Yes.
Why is this a symmetrical rotation or a non-symmetrical rotation? Look at this and tell me
Symmetrical.
why.
Because it just flips the ones it's
Say it again.
it flips, it like just moves, it's like it's the inverse.
It moves about the.
I don't know how to say it. Like the one just.
It is. What is the rotation sequence here?
It's beautiful. I don't know if he is considering this.
Because she is right. Does that make sense?
Yes, I see much.
3, 1, 3.
Yes.
Right? Symmetrical. Is that symmetrical?
Yeah.
It's symmetrical.
3, 1, 3 backwards.
Is this symmetrical?
Yes.
Is this possible?
No,
It's possible.
it is.
Oh, what do you align?
What happens if we change the sequence?
Change the axis.
Angles will change.
But so
You
but
can-
you're still aligning the ECI with.
Yes, yes. So you can always. So the thing is, if you want to go there, okay, can you go like this, and like this?
Yes.
Can you go like this, and like this?
Yes.
Yeah.
Can you go like this, and like this?
Any extension and reduction.
But the final, this thing and the initial and the final are the same. Right?
Yeah.
But you can reach there
In different ways.
different. So it's the same thing. The initial and the finals. This is the initial. This is the final. You can reach there. This is what significance does 313 have?
It's just symmetrical.
What significance does 313 have?
So you
It's the
go
same
from
thing.
ECI to PPW.
These angles. These angles are also
Oh
what?
yeah. Oh yeah. It turns
What are these angles?
Orbital elements.
Orbital elements.
Oh.
For no other sequence, you can get orbital elements. You understand? For 212, there can be 6 sequences. Okay, so 6 symmetrical sequences. I think you should make perfect this thing. So if you look at this, 1, 2, 1, 1, 3, 1, 3, 2, 3, 2, 3, 2. Can you tell me any other symmetrical sequence given these?
No.
So these are the six sequences. Does that make sense? You always need 3 rotations. You just tell me if you can figure out another sequence, symmetrical sequence. Probability. Just look at probability. Okay? Don't even look at orbital mechanics. These are your given 1, 2, 3. Your question is arrange these in a symmetrical sequence without repeating. Can you arrange 1, 2, 3 in any other symmetrical order? Probabilistically,
No.
it's not possible.
Yes.
These are the probabilistic ways. Okay. Now, if you look at non-symmetrical sequences, right? Non-symmetrical sequences means 1, 2, 3, 1, 3, 2, 2, 1, 3,
It's gonna be 6
2,
again.
3, 1, 3, 1, 2, 3, 2, 1. Can there be any other non-symmetrical sequence? Given 1, 2, 3, can you arrange it in any other way?
No.
So there are 6 symmetrical sequences, 6 non-symmetrical sequences. This is non-symmetrical sequence. Does that make sense?
Yes.
Because they are, you cannot flip it about them. These are symmetrical sequences. Okay. Here, what is this? Again, what is the significance of this?
That's only elements.
Yes.
That's how you elements.
Is this true only for ECI to PQW? Are these sequences true for ECI and PQW? For going from one frame to another?
All the first 6, yes.
Huh?
Yes, they are. The 6 are, but they just don't all use orbital.
You can apply this rotation sequence to anything and everything.
Yes.
Even aircraft. The thing is, what is unique about ECI to PQW is these angles. Okay? You can again go from ECI to PQW using this sequence as well.
Yeah.
Okay? What happens? These will not be, it will be something like R2,
Theta or something.
yes, theta 1, R1, theta 2, R2, theta 2. Okay, does that make sense?
Mm-hmm.
Okay, this is so intuitive, and that is what Euler did. You guys have to read about Euler. This is called the Euler sequence, and these angles are called Euler angles. Okay, Euler or Euler, E-U-L-E-R. He visualized this. In his mind, see, even when we have this depiction, right, in the visualization or the figure, and somebody is explaining to us, it's hard to get it completely. He could visualize this knowing so little at that time. And Euler lived just after Newton. He just did not come up with this visualization or intuition or this thought process. He also developed the entire math behind this. Okay, so you have to have that appreciation for Euler. So whenever you talk about, and this is something, it's a privilege that we get to learn this. The other thing which will be important from exam point of view is, look at this, okay? I give you the rotation sequence and the angles and ask you to derive. That is one respect. If I ask you to find out, if I give you this matrix as numbers, okay, this will ultimately be one number, right? If I give you the angles, this will be just one number.
Right.
This will be just one. Every cell will be just one number. If I just give you the matrix as a number, can you give me the angles? And if I tell you the sequence,
Yeah.
how do you give me the angles?
So if you have a number, you just basically do cosine or.
So which one will you target first? Look at this.
The bottom.
The bottom one. Yes. So the bottom one will give you.
Cosine and inclination.
Can I do? Understand this. Can I do this over this?
That over. So
Well, the eyes will cancel, the side.
Yes. So sine I will cancel. What will you get?
Yeah.
Tangent
Omega.
minus tangent omega is equal to some number. Then you get the omega from that. If I do this over this, omega cancels out. I'll get tangent I. Sorry, yeah, you're right. Tangent omega.
Small omega.
Tangent small omega. You understand? So can you do that in exam
Yes.
or when I give you as an assignment? Okay. Also, what I'm going to tell you is, so the numbers, now tell me the numbers. If I go from ECI to PQW, if I go through this rotation or if I go through this rotation, will I have different numbers?
It'll be negative.
I use this rotation, but I go from ECI to PQW. Will the matrix be the same or different?
It'll probably
We rearranged it.
If you go from where?
I'm going from ECI to PQW.
Right, that's what we already doing.
So
Oh, you're
this
saying you're going from PQW to ECI?
ECI to PQW,
Uh-huh.
that is how it is read.
Right.
ECI to PQW. You
Yeah.
don't read it PQW, you read it in the reverse order.
Yes.
So it's gonna be
It's-
different.
The math is.
Will this matrix of numbers be the same if I go through this rotation?
Oh no, because it's symmetric. Oh, it will, but it'll flip.
No. Understand the question.
Uh-huh.
I'm going from ECI to PQW.
Yes.
I use this rotation
Yes.
or I use this rotation.
Yes.
Will that matrix will be just a matrix of numbers.
Yes.
Will that be different for this and this?
Yes.
No, just your angles.
It will be the exact same,
It's with different angles, right?
but this will be different.
Yeah.
The angles will be different. You understand? When I go from one rotation to another, the matrix, the ultimate matrix will be exactly the same. You see it? How I go there will change. So I may say, find the matrix first. Now if I take another sequence, what are the angles? Can you do that? I'll say, going from ECI to PQW by 212 rotation by this angle, find the expression. Now find the angles if the rotation sequence changes. Does that make sense? What I want you to understand is, or maybe this is a little, for now, just understand this. Whenever I go from one frame to another, regardless of what sequence I take, I may take any of these 12 sequences, the ultimate matrix will be the same. Does that make sense? Okay? Please understand that. Let's wrap up our discussion with that statement. If I go from ECI to PQW, regardless of what sequence I take, any of these 12 sequences, the angles, the ultimate matrix will be the same. Angle will be different, the rotation sequence will be different. Rotation axes will be different. Okay? Does that make sense?